Okay, I'm going to give you some notes on a system called law of cosines. This is in your book in section 7.2. You've probably in the past seen something called law of sines. It's a little bit different. These three formulas, you'll notice, they are on your formula sheet, so you do not have to memorize those. And basically what law of sines and law of cosines allows us to do is find the missing angles or missing sides of a triangle. The difference between what we've done in the past is that these are not necessarily right triangles. So this system will work whether the triangle is right or not right, and then that way you can find the missing sides and missing angles. So the first example you see on your paper, it says angle B is 110 degrees, side A is 10, so that would be opposite angle A, and side C is 15, so that would be opposite side C. So this is what we refer to as a side angle side triangle. So that's what the S and the A stand for. So I can use one of my formulas. Since I've got angle B, I can use this formula with angle B, and I know A and C, so I can substitute in all this information that I have. Now I need to make sure my calculator is in degree mode because this is 110 degrees. So when I put the cosine 110 in my calculator, I get this number multiplied by the 2 times 10 times 15. Remember your order of operations. And then combine all this together and I get 427, that's B squared, square root. So B, side B, which is going to be this side over here, is 20.6786 centimeters. Okay, so that gives me our missing side. I could then use the formula again if I needed to find a missing angle. And we'll talk about how to do that in just a second. Okay, so if I wanted to find the missing angle, what I would do is take the same information that I have here. So I have my triangle. I know that angle B, and I'm trying to find, let's say I'm trying to find angle C. So I'm going to use the formula C squared. I'll move this in a second. Okay, so I would use this formula. I know that C is equal to 15 centimeters. I know that A is equal to 10 centimeters. B, we just found, was 20.6. We'll round it off to 20.7 centimeters. And then I'm going to put in the rest of my problem. I've got my 10, my B, and I've got cosine C. So if I do this math, what I'm going to end up with is cosine C equals a value, and then to find the final answer, I'll do cosine -1 and whatever I get. So in my calculator, if I put this all in my calculator, I'm going to do 15 squared minus 10 squared minus 20.7 squared. Okay. I'm going to get an answer, and I'm going to divide all that by the -2 times 10 times 20. So I'm 20.7, sorry. So I'm dividing it by all of this, and I get this value, 0.73306. And now, when I do the cosine -1, and I do that 0.73306, I find out that cosine C, that's angle C, equals 42.9 degrees. So then once I know angle C is 42.9, Now I can find angle A because they have to equal 180 degrees. Okay. Alright, so let's look at the next example. So on the next one, I gave you A, B, and C, but I didn't give you any angles. So this is sort of like what we just did. So we're going to put the, since I need angle B, I'm going to use the formula with angle B. So I have to be at B squared on the left. So I'm going to put the B squared, and I'm going to put the A squared, and I'm going to put the C squared. And then this is A and C again. I do my math, and just like before, this last step ends up being cosine negative 1, 0.86875, which comes out to be 29.68 degrees. And that's how you come up with this angle B. And then again, you could find other angles using the same process. Okay, so we haven't talked about law of sines yet, but we're going to be. But typically, if you have a law of sines problem, you're going to use one of these methods. So, for example, angle, side, angle, you all have learned about that in the past. Angle, angle, side. Remember, angle, side, side is the bad word that doesn't work, and that will work with law of sines. And law of cosines, we use these other methods, typically. Okay, so let's look at the last thing here. So you have formulas to find the areas of triangles. You know that area is 1/2 base times height. But that is true when you know that it's a right triangle, and these aren't necessarily right triangles. So here again we have an example where I have angle A is 62 degrees, I know side B, and I know side C. So I don't know that this is a right triangle, so I'm using one of these formulas to find the area. So I have 1/2, and then I'm using this formula right here, B times C sine of A, and so I can find out that the area of the triangle is 26.48. Again, I can't use your standard formula 1/2 base times height, because in that case the height has to be a 90-degree angle, and therefore you have to, this only works for a right triangle, so we don't have a right triangle, so you can't necessarily do that. Okay, so here's one more. Again, I've got angle A, and I've got angle C, and I've got 14 inches. So if I draw a picture, here's angle A and angle C. So here's angle B. I don't know what that is, but I can find it. Side A is opposite angle A. Okay, so there's where my 14 goes. So if I want to use this formula, I need to know what side B is, right? So if I want to use one of the other formulas, so if I do C, I have to know what A and B is. If I want to use A, I have to know what B and C is. And if I want to do B, I need to know what angle B is. And I don't have that information. So if I look at this, I can't solve this problem because I don't have enough information to solve it. So what we're going to be learning next is how to use law of sines to solve this. And so that's to follow. So you'll have to use law of sines first. And we'll talk about how to do that on the next video or the next class that we talk about. And the last thing you see here is something called Herons Formula. And Herons Formula is another way to find the area of a triangle. This is also on your formula sheet. So these are used as alternatives when you don't know that height of your triangle. So in this case, I'm given 3 sides of a triangle. So I can find this value of S, which is going to be a constant, and it's 1/2 A plus B plus C. So you'll notice I did my math over here and I got S. Then I'm going to use that value of S in this formula with S and A and B and C. So I write my formula out. I'm doing my math here, just subtracting, combining like terms. And so I end up with the area of the triangle is 41.23 square meters or meters squared. So I hope this helps, and we'll keep looking at this information as we go along.